In this video, I'm going to talk you through a couple different examples of the composition of functions. It's important to know that you can see whether you're supposed to do the composition of functions written one of two ways. The first way here is probably the way that most of you are most familiar with, where you have f and then in square brackets g of x and then the square bracket. And I think if you think about it, that to me visually makes the most sense, where you're going to take g and you're going to plug it into whatever is in the f function. I think most people like that way better for that reason. The other way you can see it is f with an open circle g, so f of g of x this way. It means they mean the exact same thing. It's just a matter of just different notations, and different people, different textbook companies, different professors like different notations for different reasons. But this one, you're still going to take what's closest to the x, so g, and you're going to plug it into f. But they mean the exact same thing. So if you see an example, like f of x is equal to x squared minus 9, and you have g of x is equal to square root of x plus 4. If we just start with a couple numerical examples, f of g of, let's say, 9. What you would do first is you would find what g of 9 is. So over here, we're going to take and replace x with 9. So we'd end up with the square root of 13. And then you're going to take that answer and you're going to then plug it into, so we know this is now the square root of 13. So that's what's going to take place of the x in the f function. So instead of x, we have the square root of 13 squared minus 9. So we end up with, see here, 13 minus 9, so 4. With the numbers, I definitely think that it's a little bit easier because you're comfortable with finding f of 2 or g of 7 or for specific values. Let's take a look at another one. Alright, so if we try to find f of g of, let's see here, negative 10. Alright, so we're going to start by finding g of negative 10. So take the square root of negative 10 plus 4. So we end up with the square root of negative 6, which would be I radical 6. Now, if we were just doing some operations with these functions, that's not necessarily a problem. I mean, we take this and we plug it in here and simplify it, and we could get a number. Granted, it wouldn't be a real number, but we could get a number. The problem arises if you try to graph this. So if I asked you to plot I radical 6 on a number line, on a real number line, you wouldn't be able to do it because it's not a real number. It's imaginary or complex number. So I bring this up because it's important to know that we have to state the domain of these functions. So for the domain, what you're going to do is you're going to look at the function that you're plugging in. So in that last case, we were doing f of g of x. So we were taking g of x first, finding a value, and then plugging it into f. So for domain, if we only want to end up with real numbers, we need to state the domain of this first function. So here we have the square root of x plus 4. If we want this to remain a real number, then x plus 4 has to stay a positive real number. So we say x plus 4 is greater than or equal to 0. So we end up with saying x has to be greater than or equal to negative 4. So any x value that you plug in that's greater than or equal to negative 4 is going to give you a real number or a valid output to plug into f. So not a huge deal if you're just finding like f of 2 or f of g of 7, but when we go to keep the variables in here, which we will in the next problem, that domain is going to come in handy. So we're looking at the exact same functions. If we do f of g of x this time we don't have a number to plug in, but if we did, we would know that x plus 4 would have to be greater than or equal to 0. So any x coordinate that we choose would have to be greater than or equal to negative 4. So that's important to remember for your domain at the end. So if I write this out, since I can't plug in a specific number, I'm just going to take the whole function. So square root of x plus 4. And that is going to go into, this is all going to go into where x was. So a lot of times I just like to make a set of parentheses where the x or x's were, and then know that whatever's inside the brackets here is going to go inside the parentheses over here. Alright, so whatever you're plugging in, we know the domain of it has to be greater than or equal to -4. Then when you simplify it over here, that square root squared is going to leave us with just an x plus 4 minus 9, which is just going to simplify to x minus 5. So it's just an expression. That's the composition. So f of g of x is equal to x minus 5. The domain, if you were to say the domain of this at the end, even though we ended up with x minus 5 as a linear function, because it was created with that square root of x plus 4, our domain is still going to have to be anything greater than or equal to -4. And kind of a way that you can double check this is if in your calculator you type this form of the composition. So before you simplify it at all, so in y equals, you would type parentheses square root of x plus 4, close the parentheses squared, minus 9, and take a look at the graph. The graph does look like a line, but you'll see that on your picture, on your graphing calculator, back here at -4, the line's going to stop. So if you go back even farther from -4, there's going to be no graph behind that -4. That's because only when you plug in x values that are greater than or equal to -4 will you get a real number that you can actually plot. So that's why the domain is important for those. But again, your answer for the composition here would be x minus 5, and the domain would be greater than or equal to x minus 4. Let's do one more. So for this one, we're going to use the exact same two functions that we did as the last one, but we're going to flip it. Instead of finding f of g of x, we're going to do the opposite, g of f of x. So I'm not going to start by plugging in a number. I'm going to start by plugging in the entire f function, so x squared minus 9. If you look over to what g was, it was the square root of, we had x plus 4, but we know x is going to be replaced by something else. So if we take a look at this original function, what we're plugging in, x squared minus 9. You can plug in any value of x that you want, and you're still going to get a real number output. I can tell that because there's no radical there, and there's no variable in a denominator. So currently, our domain is all real numbers. There's no exclusions. Once you plug it in, you have x squared minus 9. Really all we can do is simplify this. So we plugged in x squared minus 9 in place of x. When you simplify it, it's going to give you x squared minus 9 plus 4, which is going to give us the square root of x squared minus 5. And that's the composition. Now, we definitely don't have all real numbers as our domain, because now we have a radical sign, which means we could potentially get imaginary numbers, which we can't really graph, so we need to figure out which x coordinates we could graph. So, when you do domain of this, you're going to say, well, x squared minus 5 has to be greater than or equal to 0. Again, you want to keep it positive, say it's positive. So if we solve this, x squared greater than or equal to 5, and then we go ahead and take the square root of both sides. So we're going to get x is going to have to be greater than or equal to 5, or this is, greater than or equal to square root of 5, or x is going to have to be less than or equal to the negative square root of 5. Now the reason why we do that is when you take the square root of a number, it could be positive or it could be negative. So it's going to be greater than the positive root. And then keep in mind, like when you did solving inequalities, when you divide by a negative or you multiply by a negative, you have to flip the sign of the middle inequality. This is kind of the same thing. So this is going to be your domain. And you can look at your picture. If you graph this in y equals in your calculator, and either look at the picture or if you look at your graph, you'll see that you have some errors in between where square root of 5 and negative square root of 5 are. But outside of those values, so bigger than radical 5 or smaller than the negative radical 5, square root of 5, you'll see that you have points that you can actually plot. So hopefully that helps with composition of functions.
Made with Doodlecast Pro.